So then a few other best practices. There are a few optimizations that you can do. First, what is required is that your devices comply with the LoRaWAN specification. Also, best practice is to avoid sending many join requests. So every 10 seconds sending a join request and draining the battery, but use a backup mechanism. Also think about how often the end device sends a message. Do you really need to send the same temperature value every minute, or would you only send a change, or would you only send a heartbeat every hour, or concatenate different measurements in one larger message? So all those things are good to think about. It's always good to make sure that the message is as small as possible, because shorter messages have a shorter transmission time, which is always better for battery life, but it's also good for the overall network capacity. And finally, expect packet loss. It's not unavoidable. So make sure that your solution can still work, even if you lose maybe 10% of the messages. So allow for some redundancy. If the message is really important that it gets acknowledged by the network, use a confirmed message so that the network answers with the confirmation. But you can also use forward error correction. So you can also use data from the previous measurements and include that in recent messages. So maybe you send too much data, but at least you account for some packet loss. Also make sure that you don't synchronize all the devices so that they don't send a message all at the same time on top of the hour, for example, because then there could be congestion in the network and in the air. So use some random jitter, some random time to sleep, and also have a backup mechanism. So if you cannot join the network, you can try again with a short interval, but maybe after some time, retry only every day or every 6 hours or so. Also, if your device is not moving, but if it's fixed on a certain location, always use adaptive data rate. So let the network figure out what is the best data rate for your end device, depending on the signal-to-noise ratio. Finally, I can't repeat it enough, prefer over-the-air activation. Use persistent memory in the end devices so that after a power cycle or even after replacing the battery, your device still can restore the LoRaWAN session, or if it cannot restore the session, at least it still has the nonces, the numbers that can only be used once, so that the join procedure is unique again. And also assume that there is a link loss only after some time, after missing for example, 3 acknowledgements, and not after missing the first, because it can happen that one confirmation doesn't make the end device. Now, there is a LoRaWAN certification program that is provided by the LoRa Alliance, and the certification is something that you can get from different test houses around the world. So these are professional institutions that can test your end device and that can make sure that it complies with the LoRaWAN specification. And to make that easier, the LoRa Alliance also provides a certification test tool, the LCTT, that you can use yourself before submitting your device to a test house. So you can basically already know in advance if your device is going to pass the certification, which is a huge cost saver. Having a LoRaWAN certified end device also makes sure that it can be used on any LoRaWAN network, and that makes the addressable market for you as a device maker huge. Now, there are different LoRaWAN versions, and there has been quite some confusion about this recently. So there are certification programs for different LoRaWAN versions and for different regions. The first LoRaWAN version 1.0, the certification program is already withdrawn, and the same goes for the second version, it's 1.0.1. A very popular LoRaWAN version today is 1.0.2. It added lots of regions where you can use your device. in 1.0.3, which is essentially just a small addition to the previous version, which adds Class B and a few more regions. Then there is a huge a milestone, a big major version of LoRaWAN 1.1, which adds all these session keys. It adds supports for handover roaming, but it's not well adopted yet. It contains some really nice features, but the latest version is actually an iteration on 1.0.3, and it's 1.0.4. It has been released in 2020, and that is now the recommended LoRaWAN version to adopt. And I would recommend to wait for LoRaWAN 1.1.1, and until then, until that is widely supported and certified, and there are libraries available and things like that, and certification, the best version to use is 1.0.4. So LoRaWAN 1.0.4, it actually contains a lot of simplifications. There is a reference implementation for end devices, and that makes it very easy and quick. You can get started quickly. There is the certification test tool that's available for this version, so that also makes it really easy and also cheap to get your devices certified. And there are a few other specifications that are part of or that are compatible with LoRaWAN 1.0.4. For example, a QR code that can be used to claim your devices. So it already uses the terminology that's going to be adopted by future LoRaWAN versions. And there are a few security improvements, but they are more clarifications. So the size of the bit counter, for example, but also the requirement for persistent memory and things like that. So best LoRaWAN version to use today, 1.0.4.